Right, so this is where we left off in the previous video. We explored proving or showing why the distributive property is what it is, and this should be 4. I forgot to change those at the end as well. So 4n and 4 times 5, like we got. And down here, if we had multiple terms, you can do the same process and you wind up with the following. In this final video, we are going to tackle the most the most generalized case, at least that I can think of right now, for this topic, which is the following. So prepare yourself. Intimidating, right? Hopefully not, because procedurally, let's go ahead and look at this. C, I'm going to write it in white instead. Now I'm going to go ahead and change these C's to be in white. Notice here, I'm going to actually make these addition signs. That's probably the easiest thing to change. I'm going to make these a different color as well. Make them, let's say, make them light green. Here, color coding, you notice I'm just taking the C and I'm multiplying it by the first term. And then I multiply it by the second term. And then I multiply it by this thing. And I have this ellipses in both spots. So procedurally, you look at this and you're like, okay, I see what's going on. But you might say, I have no idea what any of this means. And so let's go ahead and break it down. And then once we break it down, we're going to try to show it using the exact same method. If you want to try that right now on your own, feel free. Or at any point, feel free to just stop the video and try. So first of all, let's kind of understand the notation here. If I write x1, versus like x2, all this means is that here I'm like, this is the first variable, one for first variable that I'm dealing with. Here is my second variable that I'm dealing with. N is just a number. And essentially, when I make a list of numbers like this, where I just count off 1, 2, eventually I'm going to keep going. So like imagine the pattern continues there. I got x3, x4, x5, ... continue on. Eventually, I'm going to get a biggest number that I'm counting to. Now that might wind up being infinite, which is fine. However, the important thing is here, we're going to stop at some point. Just because in practical purposes, we're fine. And if we didn't want to stop, then we could also write, at the very end of this, you could write plus ... and just have it continue on like that. But at some point, we're going to continue on until a certain number. And heck, why not I do that? I'll make it even more generalized. Or maybe I'll come back to it at the end. Okay, cool. But for now, let's say it stops. I'll add that little detail at the end. For now, let's say it stops at some number. Maybe that number is 5, maybe it's 3, maybe it's 100. I don't know, and I don't particularly care. Just that it stops at some point. These numbers that are written underneath and to the right of the x, first of all, that's not like x squared. Notice it's underneath, not on top. If it was x squared, we would write it at the top. That's not what that means. It's likewise, it's not 2x, because we would just write 2x if it was. This is just a way to say that this is the second x that we're dealing with, because here is the first x. And if we don't distinguish them, then we have x plus x, which is 2x. But here we want to say these are different numbers. Now, to give a concrete example here, maybe this said 1 plus 3 plus 0.75 plus negative 86.2 plus, continue adding things, and then you have like 27. Completely random numbers, and you can say first one, second one, third one, fourth one, so on and so forth, and then your nth or your final one that you're dealing with. Cool. The C is essentially the same thing. So this is like your number that's out in front. Maybe it's a 2, maybe it's something else, maybe it's a 3 or 4, maybe it's 1,000. Whatever it is, doesn't really matter. Here, it's just a number that's outside. And we take the number that's outside, and we multiply it against every part. Now lastly, this ellipses, that's the dot, 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 just means you're going to continue the pattern. So here, we're just adding each term, and so we're going to continue adding until we get to our final or nth term. Same thing here. We distribute the C to the first term, second term. You keep doing that until you get to the last term. A dot, dot, dot just means you see a pattern, and you're just representing, like, there's going to be a lot more of these. So let's just, like, it's going to look the same. Let's just omit those. Let's leave them out. Kind of imply that we're just doing the same thing, and then ultimately get to our final term. Basically, it's important to say, where does the pattern start? Well, it starts here. How do we establish a pattern, which is counting by ones? And when does it stop? That's what you need to do in math oftentimes. Right, so that's what this expression means. Let's prove it. Let's prove that this equals this. Well, to do this, remember what C means. It's some number times everything within. So some number C times all of this. Multiplication is just repeated addition. So we take this guy. I'm going to shrink it down a little bit. We take this guy, and we're going to add it to itself. And then we're going to do it again. And then we're going to do it again. And then we're going to do it again. And again. And again. And again. And again. And so on and so forth. We're just going to keep adding it to itself. How many times? C times. Now, just like I established a pattern here, I'm going to establish the pattern here. I'm going to say, I'm going to add it to itself once, add itself to itself again, and then I'm going to continue that pattern until my last time that I add it. This is like the last time, this is the second time, this is the first time. Here's all the middle times that are not explicitly being stated out. And then what I'm going to write is that I'm doing this C times, or some number of times. Maybe that's 2 times, maybe that's 1,000 times, I don't know. I'm adding, in this case, C copies. So here's 1, here's 2, so on and so forth until you get to C of them. Maybe it's 100, maybe it's 1,000, maybe it's 17, I don't know. But you're doing C of them, you're adding them C times. Well, as I said before, it's all addition. You don't need the parentheses. I'll kind of point out these main dividers. So you're adding each term or each expression. And within each expression, you have x1, x1. There's going to be a whole bunch of them in here. Each one of them is going to have an x1. And how many expressions are there? C. Some number of expressions. And so in this fashion, we say we have C copies of that first term. Similarly, we have C copies of the second term. And you might imagine, how many copies of the third term are we going to have? C. In the fourth, C. The fifth, C. So on and so on, until we get to that final term, for which we are going to have C copies. It's kind of poorly written there. Not like any of this is properly written, because I'm sloppy. But we have C of all of these. Now, this is repeated addition, so we can just say it's C copies of that first term. And here we have C copies of the second term. And we have C copies of all of these terms. And again, here, we can just list the first one, the second one, establish the pattern that's going to happen. We're just going to add one to each of these. We're going to count first term, second term, third, fourth, fifth, sixth, up into my last term where I stop. And this is what we end up with. C copies of each part. Now somewhere in this video I mentioned like we could technically continue on. Like imagine this number didn't stop anywhere, maybe like it went towards infinity. What you could write then is that you're just gonna keep going. And so here's the first, here's the second, that establishes the pattern. You can say this is what some term in the middle looks like, and then you're just gonna keep going. So I have the first term, the second term. I establish my pattern so I can continue going. I say what the some middle term is, and then I can keep going. And I could keep going. And I could keep going. And I could keep going. Yeah, so that's the distributive property in full. Essentially, whatever thing is in front, you're going to take and multiply against each term in this list of terms, so to speak, that are being added or subtracted, so on and so forth. And yeah,